Namaste everyone and Assalamu alaikum. Today I will discuss to you the statistical treatment for hydrologic data. So, for our introduction, sinasabi ng hydrologic process daw is stochastic process. Ibig sabihin lamang ito is nag-evolve siya in space and time in a manner that is partly predictable or partly random. Kagaya nga nung sa rainfall, kapag sobrang init is somewhat nag-predict natin na that there is possibility na uulan nga. And also, partly random siya kasi hindi naman natin alam kung kailan uulan. Ang alam natin is ah, kapag mainit is may chance na uulan. So, there is substantial difficulty in explaining hydrologic variable like precipitation. Kasi nga, dahil sa randomness nito is that pabago-bago, hindi natin alam kung kailan nga ba, halimbawa pag kukuha tayo ng data na ah, hindi natin alam kung kailan uulan ng malakas or kung kailan uulan ng hindi malakas. So, kailangan lamang natin dito is yung concept of statistic and probability to deal with the rainfall data. There is a substantial difficulty in explaining hydrologic variables like precipitation due to their inherent randomness. And because of the randomness in hydrologic system, sometimes mahirap siyang explain by the law of physics or chemistry. So, ang kailangan natin dito is yung statistics and probability in order for us to get the exact data. So, yung basic concept of statistic and probability is that ang statistic is a tool which is used to infer about the properties of a population based on the properties of the sample. And yung sa probability naman is ito yung nagpro-provide ng answer to the likelihood of an event occurrence provided the population characteristics are known. So, yung probability is halimbawa kung uulan, then pinoprovide nito yung possible answer na halimbawa ngayong araw is uulan, then ipoprovide niya yung answer na uulan nga. So let's proceed to the principle of probability. First is the random variable. Ang random variable naman na ito yung measurement of the outcome of a probability example. So its value is determined by chance, random variable, and are typically denoted using the uh, capital letter X. So ang random variable na ito yung posibleng outcome of an experiment. Next is the probability distribution. Ang probability distribution na ito is siya naman yung nagpro-provide ng possible value uh, of a random variable and their corresponding probabilities. So sa independent events naman na ito yung event which kapag daw yung event A is independent sa event B, ibig sabihin lamang noon is walang kinalaman yung event A kay event B. Then they are called independent events. So mangyayari, the probability of an event B is just the probability of the given B. So, yung conditional probability naman daw is ito yung probability ng event, ito yung probability if yung event B is nangyari na given that the event A has occurred din daw. So, ito namang hypothesis testing nga ito is basically, ito lang naman yung assumption or claim mo in an hydrologist. So, halimbawa, yung uh, hydro ang hydrologist has established the characteristic of sample of hydrologic data like stream flow, aquifer flow, or rain flow. There are other causative relationship which need to be established. So, dito sa hypothesis testing na ito is there are the questions that is needed to be answered. Halimbawa na lamang is yung annual flood daw ba is nag-i-increase over time or yung groundwater in aquifer ba is namimit niya daw yung standards ng water quality, namimit niya daw ba yung standard ng drinking water quality standards. So, yung mga question na yun is that uh, kailangan daw iyon siyang ma-address or kailangan siyang i-translate into statistical hypothesis kagaya ng null hypothesis. So, ang null hypothesis is usually hypothesis of no chance. Halimbawa lamang nito is gi-assume mo or claim mo is 100% clean yung water. Then lumabas sa experiment mo na 100% nga yung water, 100% clean nga yung water. Then dun yung null hypothesis mo is yung hypothesis mo doon is hindi nagbago. And which yung sa alternate hypothesis naman is kabaligtaran naman iyon ng null hypothesis. So, yung alternate hypothesis is meron siyang pagbabago. So, halimbawa, yun nga, 100% gi-assume mo na malinis yung tubig. But then, ang lumabas sa experiment mo is that um, 50% lang na malinis lang yung tubig. So, that's explain the alternate hypothesis. Ang hypothesis testing na ito yung measure of strength of statistical evidence, meaning ibig sabihin nito is yung statistical evidence provides sufficient reason to conclude for null hypothesis or yung alternate hypothesis. Extreme rainfall events and floods are hydrologic processes which are very complicated natural events. They occur whenever many parameters and variables combine. So, analyzing this using any conventional model like the rational method for peak runoff in a catchment unit hydrograph method do to yield good result. So, the statistical approach to hydrology is used for prediction of flood flows and rainfall event. However, use of statistic in hydrology is bound by limitation that many hydrological processes cannot be put to formula due to the variability that exists between events. So, ibig sabihin nito is yung some events is pabago-bago siya. So, the statistical approach for flood frequency analysis. Ang frequency analysis na ito is conducted using the available record of the maximum annual rainfall events of the region. So, in hydrology, estimating the magnitude of an event, storm or flood corresponding to the return period of such an event occurrence is of utmost importance. So, this is done through statistical analysis. So, ang statistical analysis na ito is yung past record of flood events or yung rainfall events to predict events of the future. And yung statistical studies naman na ito is use records of daily, monthly, and annual rainfall events and stream flows for estimation of large storm events and flood flows. So, for estimation of extremely large events, often the past records do not have the range of data. Often, exploitation techniques are used. Ang normal distribution is ito yung pinaka-common use distribution because of its bell shape. And the normal distribution is ito yung ginagamit natin to study the average annual stream flow or the average annual pollutant loading in the stream. So, the natural parameter of the normal distribution are mu and yung variance square. So, yung log normal distribution natin is ito yung statistical distribution na nakikita rin natin sa hydrology. So, when the hydrological variable act multiplicatively rather than having additional properties, so the frequency distribution of variables is skewed and the logarithmic of this variable is considered which follow a natural distribution. So, meron tayo ditong problem and ang pinapahanap sa atin is yung mean rainfall, variance, standard deviation, coefficient, and variation, and coefficient of skewness. So, I know na dito is napag-aralan din natin to sa data analysis. So, ganun din yung magagamit natin na formula. And basically, ang mangyayari lang doon is ipa-plug lang natin yung mga given data sample. So, ang tinatanong dito is what is the probability that the annual precipitation R in any year will be less than 35 inches. So, this side is ito yung ating what we call this the time series because the x-axis is in year and yung y-axis is the precipitation in inches. So basically, itong number na to on the table is the annual precipitation in College Station. It's measured in inches, and that means the total measured observation for 1 year. So now let's proceed on finding the total number of observation. So di ba yung given data natin, yung given year natin is 1911 to 1979. So that is 79 minus 11 plus 1 is equal to 69. So yun yung total number of observation natin. So yung sa A natin, the probability of the annual precipitation R is less than 35 inches. And this here is we are looking for the probability that R is less than 35 inches. Now, in order for us to solve this, let us count the number of observations that are less than 35 inches. So, let us count and check the number that is less than 35. So now let's count all the number that is less than 35. So we have the total of 23 over 69. Yung 69 is that is the total number of observation. So this is equal to 0.333. So this one, R is less than 35 inches. We can actually write this to whatever capital letter we want as long as we can define it. And for example, ang gagamitin natin ito is A, and that event R is less than 35 inches. So we can write this as P of A is equal to 23 over 69, that is equal to 0.33. B. Using the same technique, we are going to solve for the probability greater than 45 inches. So, tignan natin dito yung value that is greater than 45 inches. And i-check natin kung ano yun siya. So, we denoted the B as rainfall greater than 45 inches. So, we can say that probability of B is equal to the probability of B is equal to 19 over 69 or 0.275. So for our letter C naman, we are looking for the rainfall between 35 inches and 45 inches. We denote the event C for rainfall between 35 and 45. So ngayon is yung probability yung magiging probability to of C if we count the 69 number of observation, if i-minus natin yung 23 and 19, we come up with 27. We come up with a solution na 27 over 16. Since this three is complement of each other, then the sum of these three should be equal to or should be near 1. So kahit hindi siya 1, basta malapit lang siya sa 1, kahit hindi siya maging equal. And the total probability is that when we add yung lahat nito. So for our example number 2, pinapa-compare naman sa atin yung estimated probability with the relative frequency. And dito kung mababasa nyo sa ating problem is that pagkatandaan niyo yung independent processes. So yung 2 successive year of precipitation is less than 35 inches. So from our previous example, the probability that the rainfall is less than 35 inches is equal to 0.033. Then dito natin nakuha yung dito natin yung nakuha sa ating previous solution. If you say that the event D is the 2 successive years of the precipitation less than 35, then using the principle of probability, given that the 2 events are independent, we just need to multiply the probability. So the 2 successive years of is less than 35. Probability of t is equal to 0.33 times 0.33 or pwede natin gawin na 0.3t squared. Since the process is independent, we can multiply and we come up with 0.11. So, ito na yung probability that 2 consecutive years will have a precipitation less than 35 inches. So, ngayon naman is ilan daw yung consecutive precipitation do we have? So, tingnan natin yung ating previous data and let's look kung tingnan natin yung 2 consecutive data. So, to compute for probability, let us compare to the probability of the D best from the table equal. So, yung nakuha natin na 2 consecutive is 9/68 kasi we have 68 pairs and that is 0.132.